In this video, we'll go through the process of performing a simple one-way analysis of variance. Note that we're using simple numbers and ridiculously small samples so that the calculations are more straightforward and clear. Now, for this problem, we'll say that you want to determine whether there are differences in customer ratings of hamburgers across 3 different fast food chains: Burger King, McDonald's, and Burger Shot. Now, specifically, you want to know whether among the population of people eating at these 3 burger joints, do customers rate the burgers the same, or is there a difference? Maybe burgers at one of these chains are seen as better than the others. All right? We'll use the standard alpha of 0.05. We only want to make a type 1 error 5% of the time. So what would be our hypotheses in this case? Now, the nice thing about a one-way ANOVA is that mathematically, in the language of math, our hypotheses are always the same. Our null hypothesis, H0, is that the means for the 3 populations are all the same. Again, remember, our hypotheses are based on the population means, not the sample means. In English, this would be the same as saying that the mean rating for the population of Burger King customers is the same as the mean rating for the population of McDonald's customers is the same as the mean rating for the population of Burger Shot customers. And in this case, our alternative hypothesis is that the population means are not all equal. In English, the mean ratings for Burger King customers and the mean rating for McDonald's customers and the mean rating for Burger Shot customers are all not the same. At least one of them is different. Now remember, you may see some people report their alternative hypothesis as mu1 doesn't equal mu2 doesn't equal mu3, but don't do that. Technically, mu1 doesn't equal mu2 doesn't equal mu3 implies that the means are all different. But that's not correct. Mu1 and mu2 could be equal, but just different from mu3. Write out the hypothesis, okay? So that's our hypotheses. We then go out and sample 12 different diners across the 3 fast food chains and ask them to rate their hamburger. Notice it's different people at each restaurant, so the samples are independent. And again, this is a ridiculously small sample of made-up data to make the calculations more straightforward and transparent. So once we have our data, we calculate f. And to do so involves calculating a sum of squares and degrees of freedom and variance, both between groups and within groups. So we'll organize all those pieces of information in our ANOVA table. Okay? Let's get started and take a look at our data. So here's our raw data organized into 3 columns that correspond to our 3 groups. We ended up with 3 people in the first group rating Burger King hamburgers, and 4 people in the second group rating McDonald's hamburgers, and ultimately 5 people in the third group who rated the Burger Shot hamburgers. Now, notice the scores do seem a little different from group to group. But given how small the samples are and the range and variability, the F statistic will help us to estimate the probability that we just would have randomly seen differences like this if the means in the 3 populations really are all equal, if the mean ratings for the population of people eating at these 3 fast food chains really are in fact the same. Now, we'll start by calculating the within group statistics. So let's sum up the values for each group. And we see that 1 plus 2 plus 3 sums to 6 for the Burger King group, 3 plus 4 plus 5 plus 6 sums to 18 for the McDonald's group, and 5 plus 6 plus 7 plus 8 plus 9 adds up to 35 for the Burger Shop group. We then calculate the means for each group by dividing each of those sums by its respective n. So the mean for Burger King is 6 divided by 3, or 2. The mean for McDonald's is 18 divided by 4, or 4.5. And the mean for Burger Shot is 35 divided by 5, or 7. Now, while we're here, let's also calculate the grand mean. Even though we don't actually use it for the within group statistics, we'll need it later when we calculate the between group statistics. Now, because our sample sizes are not equal, we need to be careful to actually calculate the grand mean based on the 12 original raw scores, and don't just take the average of the 3 group means. If we do that, we find that the grand mean across all 12 scores is equal to 59 divided by 12, or 4.917. All right. Let's then focus back on the group means, subtracting the group mean from each of the scores in that respective group. So we subtract 2 from every Burger King score, 4.5 from every McDonald's score, and 7 from every Burger Shot score. This gives us the deviations from the group means. Our next step is to square each of these deviations in order to calculate the squared deviations from each group mean. That gives us these values, right? We then add the squared deviations to obtain the sum of squared deviations for each group, which we then add up to obtain the sum of squared deviations within groups, or the sum of squares within. Okay, now with that, we can enter our first value, the sum of squares within, into our ANOVA table. All right, there we go. Let's get back to our calculations. Now, the degrees of freedom within is simply the total n, 12 in this case, minus the number of groups, k, which is 3 in this example. So for this simple data, our degrees of freedom within is equal to 12 minus 3, or 9, which we can then, let's put that into our ANOVA table. All right, let's keep going. Finally, at least in regards to the within group calculations, we calculate our variance within. Now, I like the notation s squared within because I think it ties things together more clearly, right? But you'll also see people refer to this as the mean square within, or ms within. But if you do, it's the same thing. It's the within groups variance. And we get it, right? By dividing the sum of squares within by the degrees of freedom within. In this case, that's 17 divided by 9, which gives us 1.889, or which is our within groups variance, or s squared within. All right, so let's put that into our ANOVA table, and we've completed all of the within group calculations. So this makes a good point to wrap up this video. In our next video, we'll start with the between group calculations and then go on to calculate f, our p-value, and our substantive and statistical conclusions. All right, see you then.